Hi, if you are called John sent me this, and what it is, it's a power supply for a fire alarm for a Notifier ID3000. So this unit failed. It came out of a hospital and they replaced it, and what John said was it was very expensive to replace. So I mean, this part here, hazard a guess at how much? Well, are you sitting down? Because just this part here is £1,038. I'll just bring it up on the screen so you can have a look. And this part here is an additional £591. So in total, £1,600 worth of power supply. Now, the last time I repaired a fire alarm power supply, there was a bit of controversy about it. Because people are saying it's not certified anymore by the manufacturer, and if anything goes wrong, and who's to blame and whatever. Which, you know, I suppose it's a fair point. But don't worry, this one isn't going to be put back in service. He's just purely sent me it to see if I can find out what the cause of the problem was, and if it is possible to repair it. So this should be viewed just for entertainment purposes only, pretty much. So with that out of the way, let's have a look. So I think this part here is more like some kind of booster, like a big DC to DC converter. So I don't know what that means. That's the output of 6.3 amps. And that's the input, which seems a bit strange. I would have thought it'd be some kind of booster, so I'm not too sure on this part. Right, so let's have a look at this part first. So, do we plug it in first and see if it does anything? I mean, the first thing I noticed was this fuse here. The actual fuse holder is damaged. I'll just zoom down a bit so you can have a look. So this doesn't actually lock in because there's part of the locking mechanism there. There's actually burnt away, because it should have a little hook on it like this part, but this part hasn't. So it needs a new fuse holder, but that's not the problem why it's not working. There's obviously something internal as well. So I think I'll plug it in first. We'll use the dim bulb tester and then we'll see what it's doing. Right, got a suitable power lead. Let's just plug this in. Interesting. Right, I'll just unplug that from the dim bulb tester and we'll just try it direct to the mains to see what it does. And hopefully it doesn't explode everywhere. I should actually put a bypass switch on here, which is one of the things I haven't gotten around to doing yet. Right, so a similar result direct to the mains. Let's just unplug that. Get this out of the way for now. So to get into this, it looks like I'm going to have to drill these rivets out. Looks like 2 on that side, 2 on this side, and possibly 1 down here on the power inlet. Right, I shall go get a drill and do that. Back with the drill. Let's do this one on this power input socket. Right, I'll just give this a quick vacuum. Right, let's have a look at this then. Let's see if this top will come off now. I might need to persuade it a little bit with a screwdriver. And we're into it. Just get that bit of rivet out of the way. Right, let's zoom down and see what we can see. Oh, see a PIC microcontroller down there. This Let's just see if we can see anything obvious. Ah, hold on. What's this we have here? I'll just turn that board at a different angle, you might be able to see. Yeah, if we look at this capacitor here, that's domed, that. So that's one problem. I just wonder if it could just be that. So there's the bridge rectifier. So I wonder, there must be some chips not on the other side of this board, I guess. So I think we'll probably have to take this board out to have a look at the underside of it. Actually, I've just spotted another capacitor here. This one here. And again, that one looks like it's domed as well. Just here. So that could just well be the problem, I think. Just a couple of domed capacitors. It's got quite a few transformers in here. Right, let's see how this board comes out then. I'll just zoom back out a bit. So we've got quite a few components that are on heat sinks here, which have been riveted to the chassis. So can I get a screwdriver in there to undo these little heat sinks? Possibly. I don't know about that one though. So I think what they've done is they've riveted this after this has been placed on here. So I think the only way to remove this board, it's definitely not made to be serviced, or definitely not designed to be serviced by the look of things. So I'm just wondering if it might be easier to drill these rivets here than to try and release these MOSFETs. Yeah, not very user serviceable, or not very serviceable at all rather. Having to drill rivets out, it's not really ideal. So I might drill those out and just replace them with screws, because then you could just screw the metal heatsink back to the base. I think that'd probably be the best way of doing it. Right, we're going to start by removing these screws around the edge first. This looks very nicely made, I must say. So I wonder if this is a power factor correction power supply, because there seems to be a big inductor here near the bridge rectifier. And there's a MOSFET here, so yeah, so I think it's doing power factor correction as well. And if you don't know what power factor correction is, basically it's so the current and the voltage remain in sync, and the way they do that is switch this inductor in and out rapidly to get the voltage and the current back in phase by switching this inductor in and out. That's how that works. Right, I think we've got another 2 screws down here holding the mains connector in. Now I think the only thing holding it in now is these 8 rivets. I can't see any more screws there, so I'll drill these 8 rivets out next. Another screw down there. I'm just going to find a plastic spudging tool just to put behind here. Another screw. Right, we're an earth wire here as well, I've just noticed. Right, oof. Looks like something blew up here as well. And here. So there might be more damage to this than first expected. Right, I'm just going to vacuum these bits of metal up that all over my bench first. Right, so let's have a zoom down on this then. Right, well, looks like that ferrite bead has gone bang. Just here. That's all what's gone on there. Looks like, I don't know whether that's been touched up with an iron or something. But it seems odd why there's flux or whatever. Just here. No, I'm not sure about that chip because that chip looks a little bit discoloured there as well. Let's have a look over here. So we've got some unknown resistor here. See, there's another one there. Looks like possibly all of those three have gone. We'll check those with the meter shortly. And again, that chip there looks a bit discoloured. Seems to be flux all over this board. I wonder if this has been worked on before or something. It looks like there's a lot of things being touched up here. Like that side of that resistor there. It looks like there's another ferrite bead here, which has got a big mark on it. So it looks like the mains comes in here. I'll just zoom out a little bit. We've got a bridge rectifier, which I presume is intact because it didn't explode everywhere. And then it looks like we've got a transformer just here. Actually that could be the power, yeah, I think that's the power factor correction inductor. So I wonder if part of the power factor correction's failed. Yeah, because it looks like we've got some current sense resistors here, I think. Let's see where those domed capacitors were. So we've got one here, which is, I think it's around about here. Let's just double check that again. Yeah, seems to be just here. That's where that capacitor is. That's domed. Which is obviously near this part of the circuit here. So it looks like we've got some MOSFET here. I guess that's the gate. It looks like it switches from there to there. So let's just see if this MOSFET's short. I'll just get the test meter in shot. Yeah, so that MOSFET's short. So it looks like the power factor correction part of the circuit's blown up. But it still might work without that. I'm just trying to have a look over the circuit a little bit at the moment. I mean, obviously that's open circuit. That's open circuit. That one's not. Although then again, it could be just me measuring through the MOSFET here. So I would hazard a guess that possibly these ICs are going to be short as well. So you're going to do a MOSFET up here, I think. Actually, it could be a MOSFET or it could be a rectifier diode. Let's just see what we get on that. Well, it's not short, whatever it is, so that's good. But whatever that is, appears short. Let's just zoom down and see what that is. And it looks like a UH860G. And it says D102 next to it, so I guess that's a rectifier diode. Well, it's definitely shorted. Well, I'm not sure how successful a repair this one's going to be, if we're going to be to repair this one or not. Because we've already got some unknowns, like that resistor there. I don't know what value that is. I'll try cleaning it up with a bit of IPA, but we'll have a look. Now, I'm not going to get a number off that. I'm going to get the magnifying glass out, just to have a quick look, just to see if I can see anything on that one. So I've had a look through the magnifying glass, and I think that this resistor here is the same value of that one, because I can see an R, and then something that possibly looks like an 8, and then something that looks like a bit of a 9 there. And the only resistor that I can see that looks similar to that is this one here, and it comes from the centre tap of this transformer here, and so does that one. So I've got a feeling that that's a 0.39 ohm resistor. So I think we'll take some of these MOSFETs out, and I think there's a diode just further down the bottom here. We'll take those out and we'll see what else we can see. Now I'm not sure how far I'm going to go with this one, because ordering parts and spending money on it for it never to be used doesn't really seem very, I don't know, just doesn't seem very productive, I wouldn't have thought. So let's have a look, let's see if we can figure out what's actually blown on it. So let's take this MOSFET out. Right, just get the solder sucker on that. And it is a S9N90A. Right, let's just double check that that is short, because it could have been measuring some other components in the circuit. Yeah, that's definitely short. Let's just see if there's anything else short on here. I'll just zoom back in a little bit. Right, so that Zener diode short. That little transistor short. Possibly this transistor short. So it looks like we would need to replace a couple of transistors, that Zener diode, these 3 resistors here, that resistor there. I'm just wondering if it's getting back as far as this IC. So I'd guess those transistors go back to this IC here. So it may possibly need a new one of those ICs as well. Let's have a look at the part down here, because I think it was this component here seemed to be short. So let's take this one out and have a look at that. Right, let's get the meter back in shot. So well, I'm getting some odd readings on this. I mean, this is marked as a diode, and it looks, I'll just zoom down a little bit. Looks like those 2 pins are actually joined together there, which would make sense if it was a diode. But why wasn't it measuring okay the first time I tried it? Yeah, I've got short across there. That doesn't seem right. I'm just going to look up this part number just to see exactly what it is. Yeah, it's definitely just a rectifier diode. So I shouldn't be getting a short from there to there. Yeah, I'm not getting a short there now. Very odd. So that's blown. Looks like this MOSFET or transistor might be okay. And I think we need a couple of capacitors on the other side as well. I mean, I would say it's probably repairable. It doesn't look like there's too much damage. But I just don't know whether it's worth actually spending the money on buying the parts for something that's not really of any use to me, and it's never going to be put back in service or be used again in any way. So I don't know whether just to keep this one for parts and just leave the video at that. I'll have a think on it. So I just thought I'd have a little bit more probe about on here. Now if I just take this as a ground just down here, you might just be able to see off camera there. And this pin here is the output of the switching IC. And you can see on this chip, we're not really getting a reading. Tell you what, I'll just try and... yeah, so we're not getting a reading there. And if we're going to this chip, which is the same chip, and we're going to the same pin, we've got a dead short there. So that switching IC has definitely gone. So that's another thing there. Let's just check the output on this one, just out of curiosity. Yeah, that one's gone as well. So at least needs 2 switching ICs as well. So I don't think I'm going to go any further with this one, but at least we've diagnosed the problem and quite a few components that have actually gone. And this looks actually like 2 power supplies in itself, because if you look at the layout of the board here, it's one thing I've just noticed here. Obviously this side is the power factor correction, and we've got 2 mains caps here, 2 switching transistors, 2 transformers, 2 transformers. So I think it's actually like 2 power supplies probably either in parallel or something. I think that's kind of the way it's working. But obviously without a schematic or without any more information on it, I'm just kind of guessing as well. But I think the power factor correction circuit IC is actually okay because the MOSFET's alright. And it's actually pin 7, that's the output. As I thought it was the same as these chips on pin 6, but it's actually, this is actually a different chip. So it's actually pin 7, that's the output on this, and it doesn't appear shorted. So I think the power factor correction chip and whatever's okay, but that diode's definitely gone. So I think what's happened with this is the capacitors, like this one here, has gone faulty. It's then caused this power supply not to run properly, which is then blown. The MOSFET's shorted. It's then took out these resistors here and damaged the bridge rectifier on the output of the power factor correction. So I think that's what's happened with this. So capacitors have been the cause of it. So it's taken out the MOSFET, these resistors, and this diode here, and obviously a couple of the ferrite beads and that and stuff as well, and this switching IC and the 2 transistors and the Zener diode. So I mean, we could repair this, but I just don't see the point in going any further because it's not going to be used again, and it's not like I've got a particular use for it. So, but I think I'd find the parts probably more useful than the actual unit itself. So I think I'm just going to use this one for parts. So I think I'm going to leave the video there then. So no repair on this one, but at least we know the cause and we know probably what all the problems are on it. So like I say, repairable, but unfortunately I'm choosing not to do it on this one. So right then, if you enjoyed this video, please give it a thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.